Hello everybody. In this video we're going to be working on our concrete compression test results, and you can find the results from concrete compression test on your Moodle. If you go to concrete compression test section, you can find the concrete compression test 7-day results and 28-day results. I already finished the calculations on concrete compression test results. I'm gonna raise the sections and I'm gonna go step by step how to develop the stress and strain table for 7 days and 28-day results, as well as the concrete modulus of elasticity calculations and the table. So let's get started. So if you go step by step, first you should look at the concrete test handout and specs, concrete mix specs, as well as the sample concrete report. Let's start with the concrete sample report. In this report, you see that it starts with the objective sections, but in your report you should have your title page. So you can keep the objective same and the equipment use the same equipment because we are using the same equipments every semester. And the experiment sections, I already posted a video on YouTube. You can look at the experiment, how we prepare the concrete batch and how we perform our concrete compression test at 7 days and 28 days. And theory sections is already given. If you look at the section, concrete compression test section, you should be able to see the theory, or you can watch the previous videos. And then you're gonna come to the results. Procedure is already on the videos. You can go look at the videos and the result sections. You should have this table that includes the properties of the concrete specimen. The shape was cylinder and the diameter was 6 inch. Cross-sectional area is calculated, which was pi d squared over 4. You can look at this equation right here. 3.14 times diameter square divided by 4. So basically you can copy and paste these sections, and if you need to add the concrete modulus of elasticity, you can also add it onto your table. You should also include the concrete theoretical strength, concrete compressive strength that was advertised on the Quikrete, which was 4,000 psi, and you can find that handout right here. If you look at that section right here, table 1, typical compressive strength at 7 days is 2,500 psi and 28 days 4,000 psi. Okay. After you complete your calculations, you can include your concrete compressive strength at 7 days, 2,800 psi if it is the 2,800 psi. But in our calculations, if you have this data, you should have 2,206 psi concrete compressive strength at 7 days and 4,302 psi at 28 days. And then you should include this table, second table, onto your report, which includes the strain and stress data. You don't have to include the maximum percent deformation, but if you include it, there will be additional extra points. Then you should include this graph onto your report, and I'm going to show you how to develop this graph first, and then you can integrate it into your report. And this discussion and conclusion is up to you. Whatever you learned from the theory and the experiment, you can just summarize and describe what you have. Okay, let's go ahead and look our spreadsheet. So in this spreadsheet, before I start working on the raw data, I want to go over a couple of things, so you know what the results are. You can also find the some definitions, how to calculate the modulus of elasticity on the results, based on the results. There are two ways to calculate the modulus of elasticity. One way is to using the ACI equation, EACI, American Concrete Institute. You can find the equation here. So the equation that I used was 57,000 square root of F prime C. F prime C stands for the concrete compressive strength, which is 2206 for 7 days. I use it here. You see that cell C20 is locked here, and 57,000 square root of 2206 divided by 1000. 1000 is the conversion unit to convert from PSI to KSI. The other way is to calculate the modulus of elasticity from the elastic region. You can look at from here. This is another way to calculate it. In this case, you can read this. Modulus of elasticity of concrete can be defined as the slope of the line drawn from the stress of 0 to a compressive stress to 0.45 times F prime C. So if you calculate 0.45 times F prime C, let's see, 0.45 times F prime C, 992, and for the 28th day, this value 4,302, it is 1,935. These are in PSI, and this is in PSI. So if you come to the graph and if you look at the 992.675, it is somewhere around here. If you draw a line, and if you assume that this is a straight line, you can calculate the slope here, and that slope, which is the change in stress divided by change in strain, it will give you the concrete concrete modulus of elasticity for the 7 days. And for 28 days, you can do the same thing. You can come here, look at the value that we calculated, 1,935. 1,935, it should be here somewhere, and you assume that this is a straight line, which is the elastic portion of your graph, and you can look at the slope and calculate the modulus of elasticity. But in simple terms, you can use the equation easily, and you can calculate the modulus of elasticity based on this equation, which includes the normal weight of concrete. In this case, it is 145 cubic feet. Let's go ahead and start working on the numbers. Oh, by the way, one more thing. So if you look at here, there are two values that I manually measured. Those are the strain values. So I didn't add the axis title, so I'm gonna add the title, axis title. This is the stress in PSI, and this was the strain in inch by inch. In other words, it's unitless value. Okay, so why do I have to go through and calculate the strain value manually? Because the strain value for the maximum compressive strength corresponding to maximum compressive stress was not given during the experiment because we took the compressometer out, so this was not given. So if you look at your original file, compression test 7-day results, let's pull it up, you're not going to see this value here. One second. It's not pulling up. Well, I tried to open the original file, but I'm not able to open it. My laptop is not letting me use two spreadsheets at the same time right now for some reason. It's technical difficulty, but if you download the original files, okay, now I got it. Now it's popping back to back. So right here, this is the, okay, this one. Why it's giving me problem? Right there. Okay, this is for 7 days. So 7 days, you can calculate the strain value corresponding to stress. You can calculate the stress by dividing the applied load by the cross-sectional area, but since you don't have given deformation, change in length, you're not able to calculate the strain value. For this reason, we have to calculate the strain value manually. Okay, let's close this. Now we can go back. All right. All right. So, how I calculate the 7 days and 28-day maximum strain values. So, what I did was I used the trend line options, which you should use the trend line options right here. You can forecast the value based on the given measurements, and you can forecast what is going to be the strength and strain values based on the given values. And I'm going to walk you guys through the steps once I start from the scratch. So if I know what is the maximum compressive strength that I measured from the experiment, if I draw a straight line from the corresponding compressive stress, I can read the value on the strain, and I can get this value onto my table. So for 7 days, strain value, maximum strain value is 0.01, 11, and 12. So I got this value and I put it in my table. I did the same thing for the 28-day strength. So it was 4302 psi, and if I draw a straight line and if I look at the corresponding strain, it is 0.014. This is how I did the how I determine the maximum compressive strain. Okay. These are the expected results based on the concrete specs, and it says 2800 psi, but it is 2500 psi. That was typo, so I changed it to 2500 psi. But if you look at here, it says the 7-day strength is normally between 60% to 75% of the 28-day strength, and usually it's above 65%. So let's remove these sections. So if I delete this section, cross-sectional area, everything is going to be gone. But since you know the equation is pi d squared over 4, 3.14 times d squared over 4. See, graph is working by itself. But now I'm going to erase all these sections. So originally, this is what you receive on your Moodle. The only value was different for 7 days. It was 7,000 something 70,000 something. So I'm gonna keep the same this value since I start working with this maximum applied load. This was from the other class, but it doesn't matter. We're gonna follow the same procedure. As long as you follow the same procedure, it doesn't matter what value you use, you're gonna end up with the correct results. Okay, so let's start from the first value. So the applied load was 7012, and if I divide that load by the cross-sectional area, which is the B3 cell B3, it is 248 psi. And I can drag it down. I got the maximum compressive strength right here. And this value is missing because we don't know the change in length, but we can calculate these values. So strain, the change in length is 0.001 divided by length, 12 inch, and let's lock this cell. I can do the same, go all the way down. Perfect. So this graph is automatically projecting the forecasted value for the given data points. And let's follow the same procedure for 28 day. P is here, divided by the cross-sectional area. Oops. Now let's go ahead and calculate the remaining portions easily. Got this. And we're gonna do the same thing for the strain. Since we know this value right here is 0.01 divided by 12 inch gauge length. It's 0.01. Go all the way down. Perfect. So you're gonna do the same thing. Since you know the maximum compressive strength, you're gonna draw a line from 4,302 to the projections, 28-day trend line, and then measure the corresponding strain value. So how you can do the trend line? If I take the trend line option, I don't want to erase it right now, but I can edit this. Okay. So for 7 days, I use the polynomial trend line options with the order of 3. All I'm trying to do, I'm trying to fit this trend line with the given data points. If I do linear, you see it's not going to work because it doesn't fit with the original data points. So if I try polynomial, that's working. And for this one, let's close this. For 28 days, I use polynomial, second order. If I change the order, it's not working. So whichever is the best fit line, that's what I'm going to use. I know that if I keep taking measurements, it's going to best fit with this line. And I can forecast with different periods. I can change the period and see what's going to happen in advance by looking at the historical data, the measured data. I can measure how this concrete sample is going to behave if I increase the load or if I make some changes. So I believe it should be clear right now. And this is how you're supposed to develop your graph and chart. Graph and charts. Okay, 0.0014 and 0.001 2. And let's see one more thing. I want to see what is different on the spreadsheet that was given to you. So I believe only thing was different was the maximum applied load. As you can see, these numbers are the same, but only number is this one, 62,340. Let's copy and paste from yours. Copy and paste. So in this case, you have 2654 psi. Did it change the result? 2600 is right here. Right there. So in your case, your strain value will be 0.0015. And based on the strain value, I can also calculate the deformation. So I know the equation for strain was the change in length divided by the original length. So if I know the original length, which is 12 inch, I can multiply this value by 12 inch, and I can calculate the change in length. And I can do the same thing for here. I know this, multiply by the length, I got the deformation. Is there any changes on the modulus of elasticity after I change the 7-day compressive strain with the measured value from your spreadsheet? Yes, it did change because I changed this value. The cell automatically is calculated the new modulus of elasticity, 2,936. So, since you have all the information that you need to complete your report on your model, you should be okay to finish your concrete compression test results. What I will do, since I'm making this video later than I was supposed to, I'm gonna extend the concrete report due date 3 more days. Let's do this. Edit settings. 27. Let's make it 31st. Extra 4 more days. And save and return to course. So once you finish your report, you can submit it in this section, and you are done with the concrete compression test. Before I finish this video, I want to touch into column buckling experiment. Pretty much, I explained the